Okay, so I do not know what's happening with A. I don't know the rate of change of A because again, this is on the ground. It's also changing as well as, yeah. In the other one, I have that A squared equals x squared plus y squared. So then finally, w squared equals 25 squared plus x squared plus y squared. I do have the rate of change. Okay. I do have the rate of change of the drone. So the rate of change of the drone is dy over dx. So that's what we are given here. So dx over dt equals 20 meters per second, and dy over dt equals 5 meters per second. Okay. So we don't have anything here, really. So I have 2w dw over dt equals 2x dx over dt plus 2y dy over dt. I will simplify by 2, and I need this. So dw over dt equals x dx over dt plus y dy over dt over w. Okay, so let's see what we have and what we don't have. Very interesting. So I have this, which is 20. I have this, which is 5. And W is the square root of 625 plus x squared plus y squared. Okay, we're asked how many seconds again? 7. Okay, 7. Good. So I need to determine x. Rate times time. So x equals the rate times time. This is 7 seconds, and this is 20. So then from here, I know that x equals 140. So this will be replaced by 140. This will be replaced by 140, and this will be 140 squared. So the same y is the rate times time. So from here, y will be the rate, which is 5 times 7. So this will be 35 squared, and this will be 35. And this is only when time is 7 seconds. Okay, so now we have to plug in all those numbers. What did I do with my calculator? Here it is. Okay, so careful with parentheses here. Parentheses 140 multiplied by 20 and plus 35 multiplied by 5, close the parenthesis and divide by the square root. And now in the square root I have 625, which is the 25 squared, and plus 140, 140 squared, and then plus 35 squared. Close the parenthesis because you know me, I have to have parentheses. So what does it say? Round or something? Round your answer to 1 decimal place. Okay, so I would say that the rate of change is 20.3 meters per second. And this is our dw over dt when time is 7 seconds. Yeah, I needed to imagine what's happening here. So that's why I needed, this is the trajectory of the car. This is the trajectory of the drone. And also I had to envision the fact that the drone was 25 meters on top of the ground, right? So I had to envision a right triangle here and another right triangle in space. I mean vertical. So vertical right triangle like that. And I need to determine this, the rate of change of this. Very nice problem. Thank you for bringing that. Next question. Anybody?
I have a question on that question.
Yes.
How did you find W again?
So this is W. The green marker is W. So in order to determine this, I know that this is 25. And I need to determine this because W squared equals this squared plus 25 squared. W squared equals this that I don't know, squared plus 25 squared. How do I determine this? This is x squared plus y squared. X squared is the distance covered by the car going north, and y squared is the distance squared covered by the drone going east. So this that I'm looking for is this squared plus this squared. This squared equals this squared plus this squared. But this squared is this squared plus this squared.
Okay. I can understand now.
Is that better?
Yes.
Thank you. Thank you. Good. Next question. Anyone? Anyone? Other questions, WebAssign or otherwise?
I'd like to go over the test questions.
Yes, any, please.
Under question 1, it'd be subset I.
Okay, very good. Yes, I see it. I see it. The cosine squared?
Yes, please.
Very good. F of t equals cosine squared e to cosine 2t. Okay, very good. So f prime of x is 2 cosine e to cosine 2t times the inner function prime negative sine of e to cosine 2t times the inner function prime e to cosine 2t times the inner function prime negative sine 2t times the inner function prime 2. So there are 2 negatives and 2 2's, so I have 4, and then the rest. Cosine e to cosine 2t times sine e to cosine 2t, and no one is surprised that I ran out of room, times e to cosine 2t times sine 2t.
Thank you.
Thank you. Anything else? Other questions, please? Anything?
I have a question. But
Yes.
It's more of a general question.
Yes.
So, like, on the test, so, like, say we have, like, something that comes out complex, well, at least just, like, has a lot of terms, like this problem. Do you expect us to factor it, or just leave it as it is and move to the next question?
It's already factored. You cannot do anything.
Well, say, like, you could factor something in this problem.
I will make sure that I specify. But if we need to do something else with it, we should always have it in the factor form, actually. It's a very good question. Because of chapter 4. You will see why we always want everything factored, factor, simplified, factor, simplified. Yeah.
Okay.
Good. Anything else?
Got a silly question. In question 1, problem D.
D as in dog?
Yeah, D as in dog.
Very good.
D, we treat it as a variable, not as a constant, right?
We just did that. It was the first problem we looked at.
Okay, I just came in. a
We
little late.
don't deal in this class with functions of more than one variable. And normally the parameters are denoted by A, B, C, D, and variables are T and above.
All right, so it's a variable. Got it.
Yes. No, it's a parameter. Right. Next question. Anyone? Next question. So everything is clear then?